Hi, this video is to show how cost contingency can be managed using RiskTools software. What do we mean by cost contingency? First, it's worthwhile considering that contingency is the cost of carrying risks. And there are basically two components. Qualitative risks, sometimes called contingent risks, which are those risks that may happen. And secondly, inherent risk, which is the uncertainty associated with the work that has to be undertaken, as normally outlined in an estimate. In this video, we'll also show you how you can run a Monte Carlo for a program of projects. Contingent risk, or those risks that may happen, are assessed using Risk Valuer, which is a subset of Risk Organizer. And those of you who have seen or viewed the managed screen, a video will have seen the screen and be familiar with it. First step is to identify the risks that we have in the system that have a direct cost impact. And that's simply undertaken by ticking this box here. We've got 25 risks, and if I flip through and you keep an eye on cost impact, you will see that some have a tick and others don't. So fundamentally, you go through with a small team identifying those risks that have a direct cost impact. And all the box is doing is applying a filter. Then go to Risk Valuer, and you'll notice two things. First of all, the 25 risks that we had initially have now reduced to 14. And secondly, this line has been introduced. Likelihood, which is a preset number which can be adjusted by the administrator as a default, or indeed overwritten here, is a probability based on the initial likelihood, or the current likelihood. The team then can put in best case, most likely, and worst case values if the risk occurs. Best case could be an opportunity, so it might be a minus number. Sometimes it's worthwhile adding notes as to how the numbers are derived, so future readers of the report can see that information. Move on to the next, etc. There's a minus, there's an opportunity. When all that data has been entered, the number of iterations can be selected. It's normally the default is 1,000, but if the data is moving around a lot, then you might want to do more iterations. The default for the P level is P90, and again, some organizations like to have a different P level, such as P85 or P80. You then run a simulation, and a report is generated, comprising histogram, P50 value, P85 value. This is a little bit of an unusual shape because we've got some probably unrealistic data here. A tornado diagram, which basically shows which risks are driving the bottom line value, and a list of the input data. So one can do a check to make sure, a sanity check, that we haven't doubled up and that the numbers make sense. And that is all there is to assessing contingency for the risks that may happen. Inherent risk is undertaken using Contingency Estimator. The first step is to import an estimate, and then the various estimates will appear in Contingency Estimator's project screen. We open a project. One of the pages of that estimate worksheet is drainage. There's the description of items, unit, and obviously our quantities and rates. A small workshop needs to be held between the estimator, project manager, normally designer, and quite often customer. The workshop undertakes 2 items. It discusses each item and thereby looks at the variability of quantities and rates, and also the discussion distills where there might be errors in scope or scope elements that are missing. So the workshop discussion is very important. Entering data is very easy. So there might be 4 of those, probably maybe 6. Price might be 4,500 as a minimum rate, and probably 6,000 as a top rate, and so forth through the estimate. As we review the estimate, it may be that there are items that are no longer required or required, so we can quite quickly add a new item or delete a new item to ensure it reflects the current thinking for drainage, and we can move on to track work, earthworks, etc. A simulation is easily run by purely for this particular page by running a simulation for the group. That derives 3 reports, a histogram, a listing of the input data, and a tornado diagram. The histogram shows the cumulative values of 1,000 iterations, and if we zoom in to the bottom, you can see that our estimate item total original estimate is 148,000, P50 contingency nearly 4,000, and a P90 contingency of 12,000. So the total cost for this for drainage is likely to be about 152,000. It'll be a little bit above or a little bit below. If I want to be conservative, 160,000 is what I would use. The tornado report is particularly useful because it shows those items that I need to work on next. So these items here are driving the bottom line, and if I can get more accurate data in terms of installing concrete channel, maybe some quotes, then I will reduce the amount of uncertainty and therefore the amount of contingency I need to cover inherent risk. And that largely is all there is to it. I go through track work, earthwork, doing the same sort of exercise, and then I can run a simulation for a project. I can run 1,000 iterations, which is the default. If the information or data is moving around a bit too quickly, then I can go up to 10,000 iterations. And some organisations prefer a P80 rather than a P90 or some other value. Additionally, once the estimate's been approved, I can use this for forecasting project end costs because I can put in real data here in terms of the actual quantities used. They'd be the same value, and similarly I can use the same rate, and that will lock in that rate with no variability, so it won't affect contingency, but it will give us an input into the total bottom line. So that's probably as simple as is possible to run a Monte Carlo simulation for inherent risk. The beauty about this is that it can all be operated by the project manager. He's the one owning, or he or she is the one owning the estimate. A single source of truth, which is very important, and at any time can update the data as new information comes in. When it comes to project forecasting, I can look at last month's result and today's result, and the difference between the two is hopefully the reduction in contingency that's required. So now we have both qualitative and inherent data and models built and outputs accessible. Additionally, we can import risk valuer in data into Contingency Estimator and run a simulation across both the qualitative and inherent data. We do this by running a simulation, picking the 2 projects. This is the risk value one, here's the inherent risk, and we can press the simulation button and get the same sort of reports, histogram, input data, and tornado diagram. Whilst I'm here, I could also select not just one project, but I can select other projects. And so I can select a program of projects and run a simulation across that whole program. As before, is the histogram. I won't go through all the other reports, but you can see the civil engineering and the risk valuer information has been run as a single simulation. That summarizes what you can do with RiskTools in terms of managing cost contingency. So the key here is that all data can be managed by the project manager or his team and does not need external consultancy. I look forward to catching up on the next video.